equal to 1 plus ts. Okay, so we exercise this one. What is the difference between this from this? Basically, that simply is the inverse of that numbers. We can quickly draw it. So here, the g, j, omega, and take a log and 20. So basically, everything is the same and to there. So let me quickly do this one. So that will be equal to, if we adopt, okay, so we can do it quickly here. So that one is simply equal to 20 log 1 plus jt omega. Okay, so that's simply equal to 20 10 times log and 1 plus t omega squared. Okay. So that is the magnitude, and the other one we can calculate is phase. So g j omega equal to phase 1 plus j t omega, and basically that one equal to arctangent and t omega. Okay, so again we put into at least three situations. And so for this case, here is omega when t omega is very, very small, and at the point of frequency, t omega equal to 1, and when t omega is greater than 1. Okay, we simply tabulate, and you can see quickly, the result will be like this one. So for this case, the magnitude will become 10 times log 1, so that basically is a 0 dB. Okay, and so for this case, that will be equal to 10 times log 2, so that will be equal to 3 dB. And so for this case, that will be 10 times log of t omega squared, so basically that is 20 times log t omega. Okay, so that is the magnitude calculations. Then for the phase, here we simply plug in there. When t omega is very small, basically arctangent, and very small numbers, I would say very small numbers, equal to 0 degrees, nearly. Okay. And t omega is large, so arctangents of the large numbers basically approximate 90 degrees. Okay. So now for this case, then that basically is the arctangent 1, so that is 45 degrees. Okay. Oh, sorry, I forgot to plug the, for the previous example, never mind, I can fix that one here. So you can add it up. Okay, so from here, then we can plot it is this. Let me plot here. Okay, and this is a phase. This is in dB and in degree. Okay, first one we determine is our corner frequencies, and this one is a log t omega, so that is our t omega here. Okay, so that is our t omega equal to 1. So that is our corner frequencies. We label our corner frequencies on our plot first, and then we begin to draw the asymptotes. We know our value. First one, we know at the corner frequency, for example, here this one is, let me say this is 0 dB. So this is 3 dB, okay, corresponding to this one is 3 dB. Okay, so we label our corner frequency first. So at the corner frequencies, our magnitude equal to 45 degrees. So corresponding, right now I simply define the scale of my drawing. So at the lower frequency is 0 degrees, so that's 0 degree here. Okay, so now I have all the precise information I want to pass through. So here at the low frequency, here that is pretty much constant. And at the higher frequencies, and we know that is in slope of 20. positive 20. So here that one, this is a slope of 20 decibel per decade. So with those information, we know our curve will be pretty much like this. Approximate at the low frequency is approaching to that asymptote and then passing through this corner point, and then here tending to a positive straight line of a positive slope there. Okay? So here should be more curve. Okay, so that is 3 dB. So now for this case again, at the lower frequency, the angle is 0 degrees. 45 degrees, 90 degrees should be here. Okay, and at the higher frequencies, that is 90 degrees. So here you simply make a transitions passing through here. So you can do the curving something like this. And basically this is the third order. If you really criticize, this will be the third order polynomial, and this serving as a reflection point of that third order. But basically this is an S shape. Okay? And for the perfect example, pretty much you can use this. I forgot to draw it. This one basically is a flip of this curve. You simply flip down in the range of 0, minus 45, minus 90. That should be this one. And you can plot it. You good? Yes.
So how do we know that the corner frequency is at GW equals 1?
Yes. The corner frequency is always the first one. For the first order system per se, you look for the term TW. You simply make TW equal to 1, and that means omega W equal to, you simply make TW equal to 1, that means W equal to 1 over T. Then this is a corner frequency. So say for example for this system, let me make another example here. So say we have a GS equal to say 1 plus T1S and 1 plus T2S. Okay, so for this case, J omega equal to 1 plus J T1 omega and 1 plus J and T2 omega. So in this way, you're looking for the terms here. So you set up T1 omega equal to 1. So that means the omega will be equal to 1 over T1. This is the one of the corner frequency. Let me call omega C1. The other one is T2 omega equal to 1. And that means omega, for this case, is 1 over T2. So this is the second corner frequencies. Under this case, we should be able to determine where the frequency is for the corners. Okay? You good? A lot of fun in the cell phones. Okay, so we can take a break for the second one.